Hello out there, we're on the air, it's chemistry tonight. The electrons are charged, the protons are charged, and the atoms are in sight. Don't remember the rest of my songs. I'm focused on this crap. Is it working now? I sure hope so, or else I'm gonna eat a cow. So today we're going to look at a review of the atoms in the tables. And now? The entries in a periodic table are given by its atomic number, or the number of protons. Sodium is the 11th element on the table because it has 11 protons. Since elements are neutral, therefore the number of electrons will also equal to the number of protons. But the atomic mass is composed of the number of protons plus the number of neutrons. Looking at a cell, we've got an atomic number of 11. That means the number of protons is equal to 11. And the atomic mass on the bottom has a mass of 23. Therefore, the combined amount of protons and neutrons has to equal to 23. Well, if my proton number is 11 and my atomic mass is 23, therefore 11 neutrons will have to equal 23. Subtracting 11 from each side, you're going to get n is equal to 12. So therefore, there's going to be 12 neutrons. Now, like I said, elements like to be neutral, so therefore the number of protons will equal the number of electrons. So if it has 11 protons, it'll also have 11 electrons. So let's make a little recall that atoms are made up of three things. Electrons, which are small particles that almost have zero mass, with a negative charge found orbiting the nucleus in quantized energy levels. Protons are large particles of an atom's mass is composed of the mass of the protons and the neutrons, as we talked about before. It has positive charge, and it's found in the nucleus, or the center of the atom. The rings of electrons that encircle the nucleus follow a specific pattern. The first ring has 2 electrons, maximum of 2. The second one has a maximum of 8, third a maximum of 8, fourth and fifth have maximum of 18, and sixth and seventh have a maximum of 32. This will come in handier when we're doing the Bohr diagrams. Neutrons, again, are a larger particle that almost have the same mass of protons but have zero charge. They're also found in the nucleus. Atoms are just a combination of these three simple particles. So we're going to look at using the table. So each one of these we're going to call a cell. We're going to look at a cell, and we're going to make the Bohr diagram based off that information. Let's start with lithium. I have one started here. Lithium has 3 protons. So it has an atomic number of 3 and the atomic mass of 7. So 7 has to equal the number of protons plus the number of neutrons. But since the number of protons is 3, the number of protons has to be 3, well, we get an equation that says 3 plus 7, wow, 3 plus n is equal to 7. Subtracting 3 from each side, we're going to get n is equal to 4. So that's why I have 3 protons and 4 neutrons. Now, we said that the element has to be stable, i.e. the number of protons has to equal the number of electrons. Since we have 3 protons, we also have to have 3 electrons. Now, how many electrons belong in each ring? Well, if we go back, it says that the first ring can only have a maximum of 2. So that means I have 3 right here, so this one has to be on the second layer. Our finalized Bohr diagram. Let's move on to another example. So let's look at oxygen. Oxygen has an atomic number of 8. Well, what does it refer to again? Well, that refers to the number of protons. So the number of protons will be 8. What's the mass of it? That's 16. Since it has a mass of 16, we know that protons plus neutrons is equal to 16. We know that the protons are 8, so 8 plus what number gives me 16? It's also going to be 8. Now, in order to keep it balanced, the number of electrons has to equal the number of protons. So if there are 8 protons, there has to be 8 electrons. So let's look at building this guy now. we need 8 protons, so I'm just drag in a couple here, and then we'll do some movie magic. There's my protons. Bring in some neutrons. Again, a little movie magic. These are all located on the inside, in the nucleus, all jammed together. We have 8 here, 8 neutrons. Now we need 8 electrons. Well, we said the very first ring can only have 2 electrons, so we'll try putting 2 in. And then the next layer can have a maximum of 8. So since we already have 2, we only need 6 electrons. So put them around the other side. Normally what I do is I start at the top, and then I just move in a circular clockwise pattern until I run out, or until I have the number of electrons. So we need 6 on the outer layer, so there's my 6 and 2 on the inside. So just double check your electrons, count them: 1, 2, 3, 4, 5, 6, 7, 8. And this is the Bohr diagram for oxygen. So we can go into higher rings as well, argon having 18. So again, what's the number of protons? Well, it'll be 18. Mass in this case is 40. So we're going to get 40 minus 18, which is 22 neutrons. Number of electrons has to equal the number of protons in order for it to keep balance, and we have a lot of drawing to do. So protons, neutrons, we're going to fast forward here. That was terrible. 18 and 22. Then we need to bring in the number of electrons. Well, we know we have a full inner shell that has 2. Well, we know the second row can only hold a maximum of 8. So, oops, fill him in. So now we have 8 on the inside. So since we have 2 here, 8 here, that gives us a total of 10. We need to get to 18. Well, we need another 8. If it'll do it. There we go. Another 8 electrons. So I'm going to put those on that outer shell. Again, the atoms located on the outer shell are called valence. So this is its valence shell. If you notice, that we have a complete, since the first ring can only have 2, second ring can only hold 8, we have a complete outer ring. Outer ring, that's known as the most stable element that it can possibly be. So it's most stable when the outer valence electrons equals to the total max number that the valence shell can hold. All of the noble gases, so the farthest right column is known as the noble gas family, and it all has outer rings that are full. That's a little piece of information right there. Now let's apply the same concepts only in reverse. So we're going to complete the element cell for the periodic table based on the composition that we have of the Bohr diagram. So first of all, remember the atomic number was the number of protons. So if we count here, we've got 5. The atomic mass was equal to the number of protons plus neutrons. So if I count these up, I've got 5 and 6, so that's going to be 11. So let's just go to our periodic table to figure out what has 5 protons. So counting here we go, it tells me the numbers 1, 2, 3, 4, 5. So we're looking at boron. And you can write boron. There we go. Nice, that's the hand signature of boron. Now, is this correct? Well, we have to look at the number of electrons as well. Since we have 5 protons, we need 5 electrons. 2 on the inner layer, 3 on the outer layer. We have 5 electrons. Therefore, it's going to be balanced. So looking at, here's another example. Well, let's just skip over it for now. Blah, 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 blah. Ions, blah, 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 blah. Ions, blah, blah, blah. Anion, blah, blah, blah. Cation, anion. If you have an excess number of electrons, an excess number of protons, which means you have a loss of electrons because you lose protons. Blah, 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 blah. Blah, blah, blah. We're looking at our lithium example again. Right now we have 3 protons and 3 electrons. If we were to remove an electron, we now have 1 fewer negative charges, sorry. We have an excess positive, so this is going to be a lithium positive ion. We write that as Li+. Is this anion or a cation? Well, let's go back to the definition. Anion are atoms that gain an electron, and cations are when they lose an electron. Since we lost an electron, we have a cation. So if I were to put this back, double some of these up. Oops, this was on the wrong show. And the superscript numbers correspond to the number of electrons that is gained or lost. So in this case, we've got our lithium. It's an ion, so let's just set it as if I had it back to its normal amount was 3. But now I have 5 electrons. It has an excess charge negatively by 2, so we write it Li minus 2, and it's up in the superscript. So that's how we can tell if they're ions, if we have a different number here than what we would have, which would potentially be a 0. In this case, is it an anion or a cation? Well, since we've gained electrons, we have an anion. Now it's your turn. Show me what you know. Go to the PHET Atom Builder, which you can find the link in the D2L course. Practice by using the Atom Builder just to give you some work or practice making the atoms based off of the elements cell. Then when you're ready, you can play the following 2 games. When you choose a game, there will be 4 options. We're just going to play the first and third one. The first one is going to look at building atoms or the atom based off of the information that's given. The second one is building the element cells from the board diagram. When you finish the game and your result is displayed, take a screenshot of the result. So if you're using a phone or a tablet, you can take screenshots, usually by holding the volume down and power button, or if you're using a computer, you can use the print screen button that's located on your computer. You've done that piece though, so Control V on a computer, or if you're using a tablet of some sort, you might have to insert the picture, and then you're going to submit that document to the appropriate Dropbox. It will be graded, and we'll all be happier when it's done. So, if you don't mind, can you please leave a comment in the section below? Because I can see you're watching. I'd like to see if you can comment on it, and we'll see what that looks like. Stream health is good. I can see I have writing. Oh, figured out how to use this. Description. One watching. Oh, show chat. Any questions? Please write them in the comment feed below. Psst, you! Only one person watching. I'm waiting. Just checking out, chilling out here, see if anyone's going to respond to anything, and maybe I might have to reteach something, or etc., etc. Please pipe in anytime when you feel ready. Hopefully it's sooner than later. Christmas is coming, or winter, but it kind of is already here for the second time. Well, I've got a chat going on, but I don't know if I've got anyone in the chat. Okay, looks like I'll have some work to do with the chat then. Alright, well, thank you for watching and participating in my ridiculousness. You have yourself a good day. Bye-bye now.